Noodle Chopstick series. And we have spoken earlier, the name of the series comes from two different options that you have when you're trying to solve a problem. So when you have a problem or a question, a situation in real life or physics, maths, bio, so you can solve that in two different ways. One is more like, okay, I don't know what to call this. It's a cluttered method, it's a fancy method, beautiful method, whatever you call it. But to me, it resembles a noodle. So you want to go from A to B. That's the problem statement here. I want to go from A to B, and you may take this path, fancy path. I don't know why would you do that. To me, it's easier and more straightforward to go in a straight line path. And this is where the name comes from, noodle chopstick. Either you can take the noodle method or you can take the chopstick method. And personally, I'll stick to chopstick because to me, noodle method is really, really confusing. It is going to be very lengthy. It is error prone. It is difficult to grasp. I cannot understand. I cannot explain what's the whole point. But surprisingly, many teachers stick to that noodle method. Maybe they learned it that way. When they were a student, they learned it that way and they never questioned that methodology and they're just carrying forward. Or maybe so they don't know there is a simpler method out there. That's one reason I think of it. Another reason I always think about is maybe they want to portray the concept as a very difficult rocket science kind of thing because maybe they want to show, see how difficult this concept is. Had you not come to me to learn this concept, you would have never understood. So, student, good that you came to me. Because if I teach you something in a simple way, you might think, oh, what's the point? I could have learned myself. So I don't know. Maybe they want to teach it in such a manner that it looks like a rocket science. But to me, this is my preferred method. And if you want to make things simple and try to understand things simply and want to adopt this methodology, stay tuned and forward this video also. So my name is Bhavdeep Sethi and I am a physics converter to physics. So basically I'm a converter of physics haters to physics lovers. Many students who are having a fear of the subject, they become physics lovers as soon as they take 4 or 5 classes with me because I always teach them in a conceptual manner, in a straight line method. And I always say, do not memorize physics, and that is true for maths as well. Learn it with the nature around you. Nature is the best textbook out there. So coming back to today's topic, today we are going to talk about logarithmic properties demystified. Now, logarithms are the basic tools that is used in physics, chemistry, bio, finance. It's all around us. I mean, it's a very useful mathematical tool, but unfortunately, students are taught in a way that they get confused. It is the easiest topic of all, but when I speak to students, I really feel a kind of sadness inside of me that why are they learning in a method that, I mean, they're scared of it. I mean, it's very simple. So let's start. I mean, so what exactly is logarithm? So logarithm is abbreviated as log. I mean, log of wood maybe, but honestly, there's no relation between these two logs. This is a log of wood. It comes from a European word log. So that's where this log came from. Log, it converted to log. It's a log of wood. Now this log is abbreviation for logarithm. So there's no relationship, but just to make session fancy, I just put it there, and also maybe it clarifies things that this log is nothing like this log. So what exactly is this log? This log is actually a reverse operation of exponents. I mean, any operation, a mathematical operation has the other way around. So addition, opposite of that is subtraction, multiplication, division, sine, arc sine, log, exponents. So exponent is also called anti-log. So log, anti-log, but log is actually operation reverse of exponent. So let's see what that actually is. But today I'm going to make it easier to understand how those properties, log A plus log B is log AB, those are the things that students memorize. I'm going to tell you how logically it makes sense. You don't have to memorize. But before that, a little crash course on what is logarithm. So let us say you write 2 to the power 3 is 8, right? So that's something you know. I mean, I don't have to explain. 2 to the power 2, 2, 2. is 8. But this statement can also be written as log of 8 to the base 2 is 3. Now, see, the thing is, many teachers will say, okay, this is this, and all. And that's where confusion starts. Ke bhai, what's going on here? Let's understand what this means. So this means, so what should I raise to 2 so that it becomes 8? That is 3, isn't it? So 2 to the power 3 is 8. It's same as saying log of 8 to the base 2 is 3. Means what should I raise to 2? What power of 2 gives me 8? And that is 3. Let's do another example. So let's say I'm asking you what is log of 81 to the base 3. So I don't know how much that is. Let's say I don't know how much that is. So I'll say it is some box here, some variable here that I do not know. I want to know the answer. I want to know how much is log of 81 to the base 3. So this translates to, what this means is, what power of 3, what power of 3. So this box here, what power of 3 would give me 81? So what power of 3 gives me 81? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Yes. So 3 to the power 4, 3 to the power 4 gives me 81. So that means log of 81 to the base of 3 is 4. It is that simple. Let's take another practice here. So let's say log, how much is log of, I don't know, I'm still thinking. So let's say 125. So one log of 125 to the base of 5. Right. So I don't know how much that is. I'm saying, okay, how much is the log of 125 to the base of 5? So this statement is equivalent of saying what power of 5 gives me 125. 5 fives are 25, 25 fives are 125. Wow, I found it. So basically, 5 to the power 3 is 125. So basically, log of 125 to the base 5 is 3. That is all. So basically, these two things are same, written in two different ways. That's it. Now, is that it? Yes, that is it. I'm telling you, that is it. If you want, we'll do another practice. That is it. That is it. That is it. So let's say log to the base 10 of a million. 1, 2, 3, 4, 5, 6 is how much? So you'll say, okay, 10 to the power of what gives me 1 million? So what power should I raise 10 to so that gives me million? Okay, 10 to the power 6 gives me 1 million. That is your answer. That's all. Now, with those, there are questions. Ki bhai, why are we even studying these logs? Is there any usage of, okay, exponents were working fine. So why are we doing in a fancier way? Why are we writing this way? If this is fine. I mean, why am I introducing another complexity into mathematics subject? The reason for that is it's everywhere. And we'll see some usage of that. Richter scale, earthquakes. Some examples, I'm just giving some examples. I'm not able to give all the examples. It's going to be a book filled with examples here. Sound intensity, the decibels. Similarly, if you look at the pH levels in chemistry, you look at compound interest. So we are going to finance now. Population growth, it's all exponent. Radioactive decay, and best of all is music. If you're playing any music, so those nodes over there, so that one octave is double the frequency. So when you're playing anything like let's say piano, guitar, any music that you're playing, those nodes they have logarithmic scale, and that makes music the music. So music is all logarithmic scale. It's all around us. More examples here. So tree ring growth. Wow. Okay. Just now I said that log is not related to this log. Turns out it is, but honestly, there is no, I mean, it's not, it's just a coincidence. Okay. So that ring growth is all logarithmic scale. Now, cell division in bio, cancer growth, it's all logarithmic scale. Then fractal patterns all around you in nature. You look at the fractal patterns, and all these are basically logarithmic scales and much, much more than that. So it's not something like just a tool or a chapter that is in your textbook that okay, log chapter is coming in my exam, so I have to master that. No, it's all around us. And whatever branch of science or finance or wherever you go, log is one of the most used, and it's all around you. Even without realizing, you have log around you. So there are certain properties of logs that students memorize, and that is the main agenda of this session to make you understand why this makes sense. So one of the properties is log xy is log x plus log y. What that means is, and remember, base is some b. This has to be same base. So if this base is 2, this is 2, 2, this is 4, 4, 4. So what this means is, if I'm saying, I can say log of 10 to some base. I don't know, base maybe 1, 2, 3, 5.9 something. So some base, but that base has to be same. Is same as saying log of 2 plus log of 5. Wow, that's it. Now this is something that students memorize, but I'll tell you conceptually where this is coming from. So we are saying log of 2 plus log of 5 is same as say taking log of 2 times 5, which is log of 10. Similarly, log of 5. So let's write here. So let's say log of 5 plus log of 4 is same as taking a log of 20. So that's a property basically. But where is it coming from? We'll try to understand today. Similarly, quotient. Quotient is something like, let's say I have log of 50, log of 50 by 10. This is same as saying log of 50 minus log of 10. So basically this is quotient rule. If you're taking, right, so similarly this may be like log of 5 minus log of 3 is same as taking log of 5 by 3. Power rule. Power rule is another rule that students memorize. So basically what this is saying, log of, let's say, 2 to the power 5 is same as, you just transfer it here. You say 5 times the log of 2. So basically what this is saying, if whether you take log of 32, because 2 to the power 5 is 32, so you can take log of 32, that will be same as you taking log of 5 and then multiplying by 5, log of 2, sorry, multiplying by 5. Similarly, let's do more. So let's say what this is saying is, let's say you want to find log of 100, let's say. Log of 100 can be written as log of 10 to the power 2. Now what this property is saying, you can either take log of 100 or you can take 2 times log of 10. You'll get the same answer. So these are some properties that students memorize, and so the reason for this session is, if you understand deeply why these make sense, you can use the logs easily, not just in the exam, but in real life situation. Now another one last property that students memorize is change of base. So what is change of base? Change of base is more like, let's say you have to find log of to the base of, let's say, 3 of 1000, let's say 1000, something, I don't know. So what this property is saying, this is same as you can take the log of 1000 to some other base, and let's say base of, let's say 10, 10, 20, whatever. I'm just giving an example here, and then divide by the log of 3 to the base 10. So this is changing the base. The base was 3, I've changed it to 10. So base was 3, log of 1000 to the base 3. I don't like it for whatever reason. There are reasons, because if you look at a calculator, you will have the log to the base of 10 or exponent e, Euler's number. So you have different reason, and this session is not about a log course. This is more about proving those properties. That's why I'm not sticking to that. So log base 3 of 1000 is same as saying log base 10,000 divided by log base 10,3. So you change the base here, but then to the same new base, you take the the log of the old base. And this is called the logarithmic base change. So the base was b. For whatever reason, you want to make it k. So you want to take base k log of x. So you say no, but you'll have to divide with the new base of the old base. So yeah, that's so. Let's see how these are making sense. So the first one, let's try to see why log a plus log b is log ab. Let's try to understand why that makes sense. So let's start with taking. So let's say something. I'm just writing and I'm not even thinking at this point. So let's say x to the, or let's take it b. B stands for base, makes more sense to me. So b to the power x is something like, let's say m. B to the power x is m. And let's say, so that this can also be written as log of m, log of m to the base b is x. Right, it's the same thing. So what should you raise b so that you get m? You raise b to the power x to get m. Right. Now let's take b to the power y. B stands for base here, that's why I'm taking that, is equal to n. So now similarly, this can be written as a log to the base b of n is equal to y. Okay, good. But what if I multiply these two? If I multiply these two, what am I getting? I'm getting b to the power x times b to the power y is equal to mn. So let's say what I'm getting is b to the power x. So I'll write everything. So b to the power x times, this dot stands for times, b to the power y is equal to mn, m times n. So this can be written as b to the power x plus y. So b to the power x plus y is equal to mn, isn't it? B to the power x plus y is mn. But if you change this to the logarithmic notation, you will write. So what will you write? So you'll write log to the base b of mn is equal to x plus y is equal to x plus y. But what is x? X is log to the base b of m and y is log to the base b of n. So instead of x, I can write log to the base b of m. So I can write log to the base b of m. Similarly, y can be written as log to the base b of n is equal to this. And see how this is all making sense. Log of m plus log of n is equal to log of mn. And where is it coming from? Eventually, it is coming from the fact that when you're multiplying two things with the same base, so the powers add up, the exponents of those add up. And that's where this is coming from. When you're multiplying things, basically the powers are adding up. So behind the scenes, this is happening. That when you multiply two things with the same basis, the exponents add. But then if you take it further, when you divide two things with the same base, you subtract the exponents. And this is where you will see log m minus log n is equal to, let's do that. So let's do with a different color. If instead of multiplying these two, what if I divide it? So if I divide it, what will I get? I'll get b to the power x divided by b to the power y, which is b to the power x minus y. I mean, you're NSEP students, you understand this. So b to the power x by b to the power y is this, is equal to m over n. Now, what's another way to write this? Another way to write this would be log to the base b of m over n is equal to x minus y. But what is x? X is log to the base b of m. So what you're getting is log to the base b of m over n is equal to x. X is log of m minus sign here y. Y is log n. Isn't it so intuitive kind of thing? When you're doing log of m minus log of n, you're getting m over n because when you divide two things with the same base, the powers or the exponents, they subtract, and this is where it is coming from. Okay. Now another thing that we decided we'll work on is the the power thingy. Remember log. So what we are trying to now do is something like log of 2 to the power 5 is equal to 5 times log of 2. So let's try to see why this makes sense. So let's start with the same thingy. Let's say b to the power x is equal to m. We know this, right? We know this. So this can also be written. So how can this be written? This can be written in a different notation, and that's a logarithmic notation. We'll say log of m to the base of b is equal to x, right? So that's a log notation. Now, what if I take log? So let's raise it to some power. So let's raise it to some power, and if I raise this to some power, let's say, uh, so raise this to some power, let's say something like c, let's say. So you raise this to the power of c. Both sides, you just raise it to the power of something c. So what will this become? This will become b xc, isn't it? These will multiply together. So what you will get is b xc is equal to mc. And that's what you will get. Now you can write this in a different notation. You can write this as log to the base of b of this thingy. So you can write this as log base b of m to the power c, right? That's what you can write. So you can say base b log of this whole thing to the base b is equal to xc, right? So what this is saying is, what should I raise b so that it becomes mc? You raise b to the xc to get m to c, right? That's a different notation. But now think, what is x? X is log base b of m. So what can this be written as? This can be written as log to the base b of mc, which was on the left hand side. I'm not touching that. That's as it is. And this is c times x. So c times x, but x is log to the base b times m. So see how easy it is. I mean, and where is it coming from? It's coming from the fact that when you raise power, so this is coming from the fact that if you're doing 2 to the power 3 to the power 5, so when you're raising this, these get multiplied together. So this becomes 2 to the power 15. And this is where it is coming from. When you're raising this, it's as good as you multiplying to that. So basically what this is saying is, if you want to find the log of 2 to the power 5, you can find the log of 2 and then multiply by 5. And this is how easy, the 3-line derivation. Let's do another one. So the other one was changing the base. I mean, I'll add another slide here. So let's keep this. And then let's replicate this slide. So then and we will use it in one of the, okay. So the next one that we were interested in is basically, so let's say I have log to the base 2 of 50, let's say. This can also be written as log of a new base. I want to change the base. I want to change the base to something, 3, let's say, and say 50. Well, it says, okay, you can do that, but then you got to divide with a log of the new base here of the old base. You know, this is, we'll see why this is making sense now. So let's say we will start with changing the base, right? So how do you change the base? So let's say we'll start with the same thing. B to the power x is equal to m. So this can also be written in, I mean, this is now obvious that log of to the base b of m is equal to x. That clearly makes sense. I want to change the base. Okay, let's change the base. So some new base. I want some new base. Let that new base will be, I what should I call? Let's call it c. So what if I take the log to the base c here and log to the base here? I just can take the log on both sides and then nothing will change. So I can say I can take the logs on both sides and say log to the base c, log to the base c of b to the power x is equal to log to the base C, a new base. Base was B, I want to make it C for whatever reason of M. So what I've done is I've taken the logs on both sides. I can see when there is an equation, you can do same operations on both sides. So this is equal to this. You can add 3 here, you can add 3 here. You can add 2 here, you can add 2 here. You can minus 5, divide by 3, divide by 3. You can do same operations on both sides. So this is equal to this. I'm taking log this side, you can take log this side. Nothing changes. But now using the previous property, I know this x can come here. So this is x times log to the base C of B is equal to log to the base C of M. Right, so that's something. I'm just using the previous property that we had, right? I'm not changing anything now. But now that's a very simple algebra there. You can take this and divide it here. So what I'm getting is x is equal to log of the base C of M over log to the base C of B. But what is x? X is log B. So basically x was log to the base B of M. So there it is. Log base Bm is same as saying, okay, I want to change the base to C of M divided by log to the new base, with the new base, the old base log. That's it. I mean, this is so easy. Now, these properties are useful and we'll use them in upcoming sessions. I'll bring up more sessions on logs, but for now, let's see where I can use the logs. I mean, learning something is not useful unless I use it. So let's take a simple example here. Very, very simple. It says a bank account pays 6% interest compounded annually. So every year it gets compounded. So first year you get 6% interest, which is 600 rupees. So you get 10,600 first year. Next year it becomes 6% over that. So basically what will happen is the first year, at the end of the 1 year, you get 1.06 times 10,000. This is your money, this is your wealth after 1 year because 6% has been added to that. So this gives you 10,600. But next year, what you will get is 1.06 times of whatever you have after 1 year. So after 1 year, I had this much. So after 2 years, I get this much. After 3 years, you get 1.06 times of that. So after n years, you get 1.06 to the power n of 10,000. Right. So they're saying, okay, how long do I keep doing that so that I get 25,000? So let's do that. So we are saying, okay, so 1.06 to the power n times of 10,000 should give me 25,000, right? So we are doing conceptually. I'm not using any formula or ready-made things here. I'm just saying every year it gets multiplied by 1.06. So after n years, and that n is not known, and that's what I have to find. After n years, it should become 25,000. Okay, so a little calculation there tells me I can cancel this out, and this becomes 2.5. So basically, my problem now is to calculate 1.06 to the power what should be 2.5. So let's bring it calculator here. Now, one way is to like keep trial and errors. You can keep doing trial and errors. So let's bring in calculator. I have calculator here. I'll keep this here. So 1.06 to the power 25. So I'm saying 1.06 to the power something should give me 2.5. So I'll say to the power of, I don't know, maybe 9. Just random number I'm trying there. Oh, I only got 1.68. Okay, no. This is not what I need. So let's go more. So I'll say 1.06 to the power of 15, maybe. I'll try 15. Okay, 2.39. 2.39. Okay, good. So I need more. Dil mange more. So then I'll say, okay, 1.06 to the power 16. Okay, now this is 2.54. But remember, I don't want 2.54. I want 2.5 exactly. So then I'll keep doing trial and error. I'll say 15.8, 15.9. And I'll never get to the exact one unless I'm trying, and maybe even after that, it may not be exactly that much. So let's go back to our slide here and see how we can do it better. So the original problem is this, that I don't know how much is n. So can I not write this as, okay, log to the base of 1.06 of 2.5 is n? Problem solved. I can just find the log of 2.5 and that is my answer. That is my answer. But there is another problem. Because your calculator will give you log to the base of Euler numbers or log to the base of 10. There is no way in your calculator you will have base 1.06. That is, I'm getting stuck up now. Because calculator I can find log of 2.5 to the base of 10. But that's okay. That's okay. I just learned a property here. And I can say I can change the base to 10. I can do log to the base of 10 of 2.5. I can do that because calculator can give me this value divided by log to the base 10 of this 1.06, and that is equal to my answer n. So what I have to do now is I have to find log of 2.5, divide that by log of 1.06. So let's go back to the calculator and see how much do I get. So I'll bring the calculator back and clear everything. How do I clear everything? I think this works. I don't know if you clear everything. I don't know. Calculator should have something like this. Okay, no, it doesn't have, but that's fine. So what I'll do is 2.5, I'm writing 2.5, and then see there is a function here log, and there is log n, natural log, that is Euler's number. You can use either of them here because it's the same base, and I think it's not visible there. I'll make my video a little darker. So I might look a little darker, but at least you can see the buttons over there. So this is log. So I'm saying 2.5 log, that's this much. And then I say divide that by log of 1.06. So I'll say 1.06 and then the log of that. And then I'll say equal to 15.7252085438. See, it is giving me the exact answer. Let's test it out. So what we are saying is after these many years, my money will become 2.5 times. So let's use some approximation there. I can't remember all this. I don't know. So let's remember 15 points. So what we are getting is 1.06 to the power of this gives me 2.5. So let's remember 15.7252. 15.7252. So let's do that. 15.7252. So let's try 1.06 to the power of 15 point, and my memory is not good, but luckily there are numbers here, 7252. So 7252, then we can take more here, 0854, 0854, and let's put more, 38877, 38877. Then let's see how much you get. Look at that. You get 2.5, and that approximation is because I didn't take all the digits over there. And see how beautifully I was able to use logarithms here to calculate that value. And similarly, when you use radioactive decay and then all these analysis, cell divisions, you can use this, right? So you see that in action. And that is all. I mean, if you really liked it, I mean, you should agree with me that this was easy, and this is the way you should learn instead of just memorizing the log properties and then don't even know why they are. We just take it as a fact. Don't go into deep. That's not the way to learn. So I'll bring more videos soon. And just for your knowledge, I have started NSCP Module 3. If you want to enroll, you can enroll in that. So Module 1 and 2 are over. Module 3, we are doing mechanical properties of solid, fluid mechanics, thermal engineering, simple harmonic motion and waves. All this is the 11th portion. 12th portion starts in the month of July. So if you're interested, the course price is very cheap. It's 3 times a day, sorry, 3 days a week of classes, 6 to 7:30 p.m. on Monday, Wednesday, Friday, plus extra classes that we keep scheduling. It started on 16th of May, but you can still join because I'll be conducting some extra classes for you. The price is only 2,500 rupees and minus 10% discount with this coupon code, which is VS Pro 1. So apply that coupon if you want to have a discount, but there's a better discount here. If you buy module 3, 4, 5 bundle, that's 2,500 times 3, 7,500, you get a 1,000 rupees discount. So you pay only 6,500, but again, you get 10% off that also. So you minus 65. So 650 rupees discount on that gives you 5,850. That's it. And you have to apply this coupon, but you will also get the recordings of all the modules that you missed, 1, 2, and modules. Earlier, we used to charge 500 rupees for each module recording. We are just giving it to everybody because, I mean, Vedantu Olympiad School is not about making money, it's about making the results happen. Now, if you need any help, Ayush is there, or else you can click on the links below. And don't forget to apply this coupon, BS Pro 1. Then you get discount. Now, Dhruv actually, we studied with us and got a gold medal with in International Physics Olympiad. Similarly, Aditi and Avnish got silver in Chemistry Olympiad. And right now, as we are speaking here, so 4 students of Vedantu are going for international Olympiads. So 3 are going to astronomy and astrophysics. Out of 5 students team, 3 are from Vedantu, our students who were studying like you are studying right now. So out of 5 students representing India, 3 are from Vedantu. Similarly, International Bio Olympiad, so Biology Olympiad has 4 member team. 1 is from Vedantu. Now, obviously, we are proud of all the students here, all the 5 students here, all the 4 students here, wishing them good luck. They will get a gold medal for us. India will get a gold. But even if they don't get, for whatever unfortunate reasons, they're making us proud. I mean, this is a proud moment representing the country. And obviously, we wish all of them. But since these are our students, we have their pictures and we can showcase them. That's why the pictures are here. But proud of Team India. So, and also just to let you know, I'm conducting a webinar for the parents because sometimes parents think if the student is studying for Olympiads, he or she may be suffering the rank in JEE or NEET. I'm conducting for them role of Olympiads in JEE and NEET journey. The agenda is to explain your parents what is the role of Olympiads in JEE and NEET journey, and also how you can fit the Olympiad preparation in your study plan for JEE and NEET. So you should actually, so I don't have the link here, I think on the description box. What you can do is you can join this Telegram channel. I'll be putting the links over there. So 31st of June, which is on Friday, time is 8 p.m. so that the parents are home from their work or household duties. And you should also join with them. So join this Telegram channel. This is the channel, but if you go to that paid course, you will get entry into a group, Telegram group where you can ask doubts and also get weekly, not weekly, after every class you get an assignment and then on Sundays you have a test also. So students, keep up the high josh, keep learning conceptually, never memorize things, and I will see you soon. So share, like, and subscribe to this channel. Bye bye. Take care.